If you plan to become a data scientist in 2025, then stick around. I will show you which 5 skills you need to master and what is different when your target is applying data science in a highly regulated and fast-paced field like finance, with a huge amount of data. Let's dive in and break them down one by one. At its heart, data science relies on programming and math to unlock actionable insights from complicated data sources. Success in these fields means mastering everything from coding and math basics to data wrangling and engaging storytelling. Along the learning process, keep always in mind the 80-20 rule. Expect to learn 80% of each skill's main functions in just 20% of your study time. Those are the parts you will use most often. The remaining 20% will take additional practice and refinement during your first jobs. And thanks to GenAI, 2025 will be a whole new ballgame for learning. By mastering GenAI platforms like ChatGPT and Claude.ai, you can accelerate your results. Stick around because during the video and at the end, I will show you how. The number one skill is Python, the go-to language for data science. It is a very beginner-friendly and relatively easy to learn language. In about 2 months, you will have a good basic knowledge of it and can start creating your first projects. After you build up confidence with Python, move on to SQL, short for Structured Query Language. You will notice it's not too different from the way Pandas data frames are structured. In just about a month or two, you can learn how to efficiently create select queries, insert, and update queries. And in the description below, you will find affiliate links to some of my favorite books that helped me level up my skills. Delete or manipulate data from databases like PostgreSQL, MS SQL, Oracle, or IBM DB2. Next, understand Git, a version control system for tracking and collaborating on code. As a beginner, I would recommend you knowing the pure basics, so that you will master it within your first job. Spend a maximum of 1 or 2 weeks on this. And to start mastering programming, focus on data structures and algorithms to sharpen your problem-solving skills. They are essential for tackling tough challenges and nailing interviews at tech giants such as Amazon, Facebook, or even your local bank. Plan on dedicating 1 or 2 months in addition for this. Next, you need to have a solid and crucial knowledge in data wrangling and cleaning. For getting your data, you either use SQL when the data is already structured, or you use web scraping with tools like Request, Beautiful, Soup, or Selenium. You can also pull information from APIs and work with various file formats such as CSV, JSON, or XML. Once you have your raw data, it's time to clean it up. That includes handling missing data, outliers detection, and duplicates, plus doing some feature engineering and feature selection to refine your dataset. This is often 99% of the time done with pandas and NumPy. Next, you will transform that clean data into a format that's ready for modeling. This is where you normalize, scale, encoding category variables, and even combine multiple dataset skills come into place. Pivoting tables can also help organize everything for seamless analysis. Let's wrap everything up of data wrangling and cleaning. Set aside at least 2 to 3 months to learn these skills because they are the foundation for smooth data science process. Keep in mind that you will invest around 80% of your time here, with the remaining 20% spent on modeling. After having a solid foundation on programming and cleaning our data, we need to build the foundation of modeling. So let's shift our focus to mathematics and statistics. First, there's statistics and probability. You will be looking at concepts that you will help interpret and predict patterns from data. Next, we dive into the structures behind the numbers. Linear algebra is key for working with matrices and vectors, essential building block for data operations and transformations. Calculus underpins how we handle changes and trends within our models, especially when refining them for higher accuracy. And finally, we can't overlook the methods that make everything more efficient. Optimization methods ensure our models run at their best, helping us find the most effective solutions. And that's the core of mathematics and statistics. Let's keep the momentum going by investing about 2 to 3 months into those topics. Awesome. By now you've likely spent around 8 to 9 months mastering Python and SQL, data wrangling and mathematics and statistics. So we are officially halfway there. Now let's dive into machine learning and modeling. Before deep learning and generative AI took center stage, we had great and solid algorithms like linear regressions, logistic regression, and tree-based models. These are still vital for many projects today. But when we talk about classical algorithms, we usually categorize them as supervised, unsupervised, or reinforcement learning. In supervised learning, we have methods like linear regression, logistic regression, and tree-based algorithms. For unsupervised tasks, you might use clustering approaches like k-means or hierarchical clustering. Reinforcement learning is a bit different. It's all about learning through rewards and penalties, often used in robotics or game playing scenarios. But let's see what's next on the cutting edge. Neural networks power everything from image recognition to NLP, natural language processing. Mastering those frameworks like TensorFlow or PyTorch can open huge possibilities. Of course, building a model isn't the end of the story. Here you will use cross-validation metrics like accuracy and F1 score and tuning methods to ensure your model is both accurate and reliable. And finally, let's take it to the real world. Once your model is ready, deploy it with via API, dashboards, or fully integrated applications. And continuously monitoring performance is crucial for long-term success. That's your quick intro into machine learning and modeling. Keep pushing forward, but plan to spend about 4 to 5 months getting comfortable with the core LLM concepts and knowing when to use them. Then give yourself another 2-3 months to explore deep learning, especially the basic of LLMs like transform models, because GenAI is taking center stage right now. After having created your first model, you need to get good at results and data visualization and storytelling. Tools like Tableau or Power BI can help you present data insights in an interactive, visual, appealing way, perfect for sharing with stakeholders. But Python integrated tools such as Matplotlib, Seaborn will do the job at the start for presenting results and visualization insights. But shiny visuals aren't enough without strong messaging. Storytelling is the key. Whether it's a polished report or an in-person presentation, your goal is to make complex ideas clear and actionable. Check out this great book about storytelling. I put the link inside the description. That will be your blueprint for data visualization and storytelling. So let's move on after you have a solid foundation after around 1 or 2 months. By now, you've spent roughly 12 to 15 months and built a solid foundation in all key aspects of data science. So what happens when your data becomes truly gigantic? It's called big data. Let's explore. If you're processing truly large data sets, you might need advanced tools and infrastructures to handle the volume efficiently. Frameworks like Spark or Hadoop can help you split huge jobs across multiple machines, speeding up data transformations and analysis. Invest 1 to 2 months, and those tools will help you able to find insights and trends you wouldn't be able to catch with small amount of data. Great, but those tools need an infrastructure, right? Yes, and here's where cloud comes into the game. So let's talk briefly about offloading that work to the cloud, where platforms such as AWS, Azure, or Google Cloud offer managed services for storage, analytics, and machine learning. So you can focus on the data science rather than server maintenance. Often people are oversaying this step, but it's crucial. 60 to 80% of data science projects make it never to production due to the following 4 reasons: lack of business alignment, data challenges, operationalization difficulties, or ethical concerns or compliance. Knowing this will make you stand out from the mass, so invest 1 month in this topic by first identifying the data protection regulation you have to follow. In Europe is General Data Protection Regulation called GDPR, which applies to how you collect, store, and use personal information within the European Union. In the USA, it is the CCPA, or California Consumer Privacy Act. Check your country, which regulations are applied, and understand them. Coming soon is another major piece of legislation. When you see this video, it is probably already in place, the European EU AI Act. This act focuses on the ethical and safe development of AI, placing certain algorithms and applications under strict policies to protect user rights. And speaking of user protection, it's not just about the following rules, it's all about making sure AI systems are fair, transparent, and accountable. That means being ready to explain how your model reached their decision. So if you're working with data in any capacity, remember, it is crucial to keep an eye on these regulations and strive for both ethical and explainable AI. And now, our final step: domain knowledge and soft skills. Understanding the industry or sector you work in, finance, healthcare, marketing, helps you frame the right decisions and interpret your findings accurately. These are the human elements that tie all your technical expertise together, helping you deliver real impact. It's not just what you know, it's how you share it. Whether you're crafting a detailed report or giving a pitch, Clear communication, compelling storytelling can make the difference between a data project that gets noticed and one that doesn't. Working well with others like software engineers, product managers, or stakeholders ensure your data science projects truly succeed. Now, if you are setting your sights on finance specifically, domain knowledge means understanding financial instruments like stocks, bonds, and so on, along with regulatory environments and market dynamics. When you speak the language of portfolio managers or risk analysts, you will collaborate more effectively and build models that align with real-world financial goals. So there you have it. The right blend of industry knowledge, interpersonal skills, and a hunger to keep learning can be the real game changer for your data science career, especially in finance. Staying curious fuels your ability to grow with the field. Keeping experimenting, keep reading, and never stop sharpening your skills. With 3 to 5 hours of focused practice every day, you can follow